Hi, I'm Jacob David. I'm a Senior Tech Service Advisor here at NGH. Today we're going to be talking with Aaron in engineering to talk about some installation considerations that hopefully we can alleviate some of the mystery behind A2L before the upcoming launch.
Yeah, so I'm Aaron Embry, Director of Engineering Group, and here with Jacob today to talk about some of the practical considerations when you're going to do your first A2L install with our equipment. So if you have questions while we're talking, feel free to go ahead and enter those through the video player, and we'll answer them here once Jacob and I have gone through some of these basic requirements. So with that, Jacob, what's your first question?
First question I have for you is that if I was going into a distributor and I wanted to buy some equipment, I heard something about having to charge the system according to the square footage of the house. Can you elaborate on that a little bit?
Yeah, absolutely. So when you're selecting a piece of 454B equipment for your job site, you're going to do all the same things you did before with regard to load sizing, making sure you have an AHRI match, and those kind of considerations. But there's a few extra things to think about, and one of them is the amount of charge that is in the system versus the area of the space that it's servicing. And so the reason that's important is, if you remember from some of our previous discussions, the ignitability of a gas in air is a function of its concentration, right? So there is a concentration at which the refrigerant becomes ignitable. And below that concentration, it's not. And the safety mechanisms around leak mitigation are all based on keeping the refrigerant below that concentration, right? So what the safety standards say is that would there be a leak inside this piece of equipment, that the blower is going to activate and it's going to distribute that refrigerant from inside this cabinet through the rest of the structure. And so that rest of the structure has to be a big enough space that should the entire charge of refrigerant exit the equipment and get into the structure, we're still below that ignitable concentration, right? And there's a factor of safety on that too. We want to be well below it, right? And so what that looks like, and I have a piece of our literature here. This is going to be your best friend when it comes to installing these. This happens to be our C75 case coil instructions. And on page 15 of this, this is a web printed out version. It also comes with the equipment, of course. There's a chart. And this chart compares the total amount of refrigerant charge to the total conditioned area. And essentially says that as long as your conditioned area is above a certain square footage for a given amount of charge, that is a acceptable installation size. And so let's define that conditioned area a little bit, right? So when you're thinking about the square footage that this system is servicing, it's not going to necessarily be the square footage that you might see on a real estate listing for that building, right? It's going to be similar to the square footage for your load calculation, but here's really the requirement. Everywhere that you can count towards that square footage, which we'll call the dispersal volume, right, has to be connected to the system by a supply and a return. So if I had a room that only had one of those, that wouldn't count towards my total square footage. And if I had a room like, say, a basement that was not serviced at all, I also wouldn't necessarily count that towards my total square footage. You can count spaces that have a supply but no return, as long as that room is connected to the return via transfer ducts or open passageways with no doors, right? So all that's listed out here in detail, but you're going to want to calculate, and we recommend the way to do that is actually go through the structure, find all the supply and returns, and measure out those square footages. And once you have that number, you're also going to have the charge weight, which will be the final charge weight after line sets, right? And in fact, the charge is something that you're going to record on the equipment. And you're going to compare that total charge weight to this chart and make sure that we're still in this good zone here. And of course, you want to do that before you ever purchase the equipment to make sure you're picking something that'll work. Now, in the vast majority of cases, I think you'll see this is not that restrictive. The very largest system as far as charge weight that we offer right now with a 150-foot line set, it'd be a 5-ton, 2-stage heat pump, has 14.5 pounds of charge, which requires 213 square feet of conditioned space, which for most homes is not that big.
Okay. Well, and that brings up a good point too that we should probably reiterate, and that is we really need to go over the install instructions thoroughly before we install.
Yep.
Regarding line set, brazing inside the cabinet is thoroughly important.
Yeah. Any braze joint is a potential leak site, right? And so in addition to the conditioned space that this equipment is servicing, there's also the space that it's physically in, right? There are some requirements for that space as well. If the equipment is in the conditioned space, meaning that there are supply and return access to that equipment, then you can count that as part of the total square footage that we just talked about a second ago, and that would be acceptable. If it's not, you may have to see, first of all, is the space it's in large enough? Is the space it's in larger than the minimum required area, in which case that would again be an acceptable installation. Or you may have to do something like add a transfer duct or add a supply or return to turn the space this is in into a conditioned space. Or if you have a braze joint outside the cabinet, you may have to do something like supply ventilation to the space around this piece of equipment. But if you can keep all of the braze joints inside the cabinet, then all the potential leak joints are in the cabinet and covered by our leak detection sensor. So a way you can do that is by running the line set into the equipment and making the braze joint inside, in which case our leak detection system covers any leak at that joint.
And speaking of the leak detection system, normally with our standalone coils, we're going to have cable coming out, and that's what we're going to be wiring to the furnace, correct?
Yeah, so we'll show this in a future video, but there'll be a cable coming out of here with 6 wire connections. We've talked about these before, and you're going to make the connection between the sensor, the thermostat, and the outdoor unit inside the cabinet of the furnace.
And they have the ability to add on an external alarm system if they wanted to.
Yes. So there is an alarm output that can be used for whatever your local code might require. Another thing to consider on these installations is the existing duct system. So if you have a zoning system in particular, earlier we talked about the conditioned space that this system might distribute leaked refrigerant into. Imagine that you do the calculation, you see, oh, I'm fine, I'm above my required minimum area. If I have a zone system though, and that zone system might be configured such that it's delivering to a much smaller part of the structure, you have to also check if that smaller part of the structure is also above that minimum requirement. And if it's not, what you'll need to do is use the alarm out on our RDS to tell that zoning system to open all zones to make sure that should we have a leak, we're distributing that refrigerant through the entire structure instead of just into a couple of rooms that might be the smallest size zone that the zoning system is set up for.
Right, got it. Back to the line sets though, I had another question, and I'm sure somebody's going to ask me too on the line, is do you have to replace the line set when you go to install a new A2L system?
Yeah, no, not necessarily. There are some things to consider though. We don't want the line set to be in an area that is unventilated and unable to be inspected, right? Where there might be a leak that would accumulate inside a volume in the wall and no one's able to tell, right? So you're going to want to inspect the line set, and there are some, again, detailed requirements in our instructions to talk about that, but making sure that it is all accessible, and also if it's in a garage, we want to make sure that any line set routing is protected from being damaged by somebody moving near it or something like that, right? And there's a few ways you can protect the line sets.
Okay. Now, when I'm going to purchase an A2L system, I've got a bunch of cans of 410A left over. Is that something I'd be able to top off with A2L?
Absolutely not. So yeah, no mixing of refrigerants, and you may not turn this into a 410A system either, or vice versa. So once a system is set with a certain refrigerant, that's the kind of system that it is. And yeah, no mixing of indoors and outdoors. We want to match 410A equipment, 410A equipment with 410A equipment and 454B equipment with 454B equipment.
Got it.
Yep.
As far as the thermostat is concerned, is there any special thermostat that you need? Can they use any thermostat?
Nope, they can use any thermostat. Our RDS system is going to basically be placed in between the thermostat and the rest of the equipment, and it's compatible with any single 2-stage communicating, non-communicating thermostat you might use today.
As far as the outdoor equipment, I see there's a lot of labels here. I also see some red caps. Is there any changes other than that? that we need to talk about?
Yeah, so your outdoor install experience is going to be more similar to today than the indoor is. There's not as many things to consider, but yeah, we know this is a A2L equipped system because of the red caps, as well as the warning labels. There are a few component changes. Some of the electrical components, like the contactor, have been changed over to A2L ready components. So we want to make sure when we're doing replacements of those components that we're using the correct A2L versions. But other than that, best practices on install are still best practices on install when it comes to pulling the system down, pulling a vacuum, flushing with nitrogen. We're going to want to do all those things just like we did before that were always best practices.
And along the lines of the components, I believe the defrost board too has changed a little bit.
Correct. The defrost board also has some relays on it, and those have been changed over to relays that won't generate a ignition source.
Okay. And is there any need for a sensor outside, or?
Nope, there's no need for a sensor outside. Now, package systems, some of our package systems will have sensors, but they protect the indoor evaporator side of the package system, not the outdoor condenser side.
Very good. I understand we're still using the same gas furnaces. There's not really any changes to be done on those.
That's right. So our residential gas furnace model numbers are not changing as a part of the transition to A2Ls. Everything that is A2L enabling about the equipment is in the case coil.
Okay. What else is there that we need to know regarding install instructions and local codes and things like that?
Yeah, great question. So we highly recommend that you find these instructions and read them before you go and do your first install. Take a moment at your desk and familiarize yourself with them. There is a lot of information here to help you do the install. In fact, in particular, again, this is the C75 installation instructions. On page 5, there's a section called Pre-Installation Inspection for A2L Systems. And it covers 5 areas. The determination of that square footage per charge we already talked about. It talks about inspecting the space, like we talked about. And it talks about the duct system and some of the zoning requirements. The inspection of the line set piping system, and also the importance of reading these instructions. And you are able, as you always have been, to use one of our case coils on an existing furnace, which may or may not be an NGH furnace, or may be an older NGH furnace. This is compatible with all of those through thermostat controls, but it's very important to read the instructions for that other device as well and understand how our RDS works, and how the blower activation in particular of whatever air mover you're using works, so that you understand the interaction between those two. Remember, at the end of the day, what we want to happen is if this detects a leak, we want the blower to activate at a cooling speed. Also, there may be local code requirements that you need to look at, and of course our instructions are going to tell you to do that, but familiarizing yourself with local codes, with ASHRAE 15.2, and the instructions of all the pieces of equipment involved in installation is the best way to make sure you're making a quality A2L installation.
Very good. Well, Aaron, I think that wraps up most of the questions I think we'll get starting off in tech service. So appreciate you being here. I think we got a few more live questions up at the desk. We want to head up there.
Sounds good.
All right. Thanks, guys. Welcome back. Thank you for tuning in today as we try to answer some of those more difficult questions regarding A2L and surrounding A2L. So we're joined here again with Aaron. Thank you very much.
Glad to be here.
Yeah. Well, we had a lot of questions rolling in, so let's go ahead and start with some of those. Aaron, first question that I think is still relevant from what we actually just learned downstairs, but I feel we should reiterate, is the fact that we still have braze connections inside the cabinet as opposed to outside the cabinet like we've done previously. So why did we make that decision?
Yeah, that is a change from our current 410A product line. And that was done to really make it as easy as possible to make a good A2L installation. So our refrigerant sensor inside our cabinet protects all of the joints that are inside that cabinet from undetected leaks. So if we have a leak in one of our joints inside of our equipment, our sensor will detect it and activate the mitigation equipment. Any field joints that are made outside the cabinet are not protected by our sensor. So by putting those line set joints inside the cabinet, they can take advantage of being detected by our sensor as well.
Great. Yeah, that makes a lot of sense. Was there anything else regarding joint connections outside of the cabinet coil besides just what's allowed inside the cabinet?
Yeah. So it's still possible to make joints outside the cabinet, but we're going to want to be mindful of ignition sources and keeping that joint at least 10 feet away from anything that could be considered an ignition source. And also thinking about if you have a joint outside the cabinet, the size of the space that is in per some of those minimum square footage requirements we talked about earlier.
Right. Great. Thank you. We got a lot of questions, so I'm going to move on to the next one here. But changes to the furnaces. Are we going to be having any changes to our furnace product line?
So residential furnaces, no. Everything that is about A2L and leak mitigation is in our cased coils when it comes to residential furnaces. Now for manufactured housing furnaces, that's different. The manufactured housing furnaces have coil cabinets that are integral to the furnace cabinet, and so we do have some changes to those furnaces. There are new models associated with those changes, and we have kits to convert an existing unit in the field to have those same changes when you're going to apply a 454B piece of equipment. Yeah.
Very good. Moving on here, we have another one that I think we've talked about in the past, but would be important to reiterate, and that is, are we allowed to use mechanical joints here instead of braze joints?
Yes, you absolutely can still use mechanical joints. The things to keep in mind are that the joint needs to be approved per UL 207, and it needs to be done per the manufacturer of the joining equipment's installation instructions. Brazed joints, when done properly, are still best from a prevention of leak standpoint, but you may use a mechanical joint as long as it meets those requirements.
Okay. And along those same lines here, are we allowed to use the same line set? Can we change the lines, or can we keep the same line set that's in there without changing it?
Yeah, so you don't have to change the existing line set, but there are some things to keep in mind, and those are gone through in detail in our installation instructions. There's a whole section about that you'll want to take a look at. But you can reuse the line set, but you need to be aware of any places along its run where it might be unable to be inspected, or you might have a joint you're unaware of that could potentially leak and fill a cavity inside the wall or something like that. So you need to be able to inspect the full run of the line set, and there may be situations where you're not able to do that, and you may have to have an alternate route.
You have to visually see
Right.
the whole entire line set.
Yep.
Okay. There's a really good one in here that I wanted to ask you. That was, this person asked, does the 400 square foot per ton rule of thumb no longer apply because of the precise load calculations that need to be done?
Yeah, that is a good question. So I think they're asking about, loading calculations. And the way that you do load calculations to determine the capacity of the equipment required for a given structure, those don't change with the new refrigerant. And whatever method you were using before is going to get you similar results as today. If you were being very precise and measuring every space, you want to still do that, you may do that here. That is the best way to do it. If you were using a rule of thumb or an estimate, that rule of thumb or estimate is going to be just as effective with 454B as it is with R410A. The new thing to think about when it comes to the size of the structure is the minimum square footage of area for refrigerant dispersal that we talked about earlier, which really, that on its own doesn't have anything to do with the capacity required. That's about making sure that we have a sufficient air volume to distribute any leaked refrigerant into.
Very good.
Yeah.
Thank you. Moving on to more along the lines of the sensor.
Yeah.
Does the sensor that we're using have to be manually reset, or is that automatic after it trips? Will that eventually reset on its own?
Yeah, so let's talk through the sequence of things that happens when we see a leak at the sensor. So when the sensor sees a leak signal, it's going to activate mitigation mode, which means turning off the compressor, turning off any heat sources, and turning on the blower at the cooling speed, as well as energizing that alarm output that we talked about. And so as soon as that happens, that is going to stay on. It's going to stay in that mitigation mode for as long as it sees a leak signal, plus 5 minutes. So when that leak signal goes away, it's going to continue to be in mitigation mode for 5 minutes at least, and then it's going to go back into normal operation mode. So that is automatic. You don't have to manually reset it. There is no lockout, right? And what's likely to happen, this depends on the size of the leak, right? But what's likely to happen is a leak will be detected. The blower will activate, which will start dispersing that refrigerant, which means the sensor is going to not see that signal anymore. 5 minutes is going to pass, and if the leak is small enough that you haven't lost all the refrigerant in 5 minutes, the blower is going to shut off. That leak level is going to rise back up again, right? And it's going to see that leak signal, and it's going to turn the blower back on again. And that could happen possibly several times until you're out of refrigerant, right? And then it's going to go back into a normal operation mode as soon as it doesn't see any more of that refrigerant inside the cabinet.
Okay. Yeah. Well, hopefully that puts people's mind at ease.
Yeah.
That it's not so bad. Another good one here. If somebody were to accidentally mix, say, Fortinet with R454B, how flammable is the unit at that point?
Yeah, that's a great question. And probably the best thing to do there is just start over. So once you've done that, you don't have R410A anymore, and that's important from a flammability standpoint and from a refrigerant properties standpoint.
Yeah.
So if you've detected that you've mixed those refrigerants, that needs to be fully evacuated, flushed, and that's a do-over there. Yeah.
Along those same lines, I think it may have been asked before, but so do we, and I'm sorry, with the NGH furnace, when installing a new furnace, can you use an R454B cased coil with an existing furnace? I believe is what the question's asking.
Okay, excellent. Yeah, so with our residential products, if you have our R454B cased coil, you can apply that to a furnace that's ours, that's from years past, or with someone else's furnace. And the way that is done is through our RDS and how it interacts with the system. So our RDS effectively sits in between the thermostat and the rest of the system. And normally it just passes through the signals the thermostat is sending for heat or cool or what have you, right? But when a leak is detected, the thermostat or the RDS ignores what the thermostat is doing and starts sending the equipment signals to operate. So because we use that thermostat interface, lots of different furnaces, obviously work off of Y and W signals, right? So that can work too. The really important thing there is to read and understand our instructions about how the RDS works, and read and understand the furnace that you're using and how its blower activation works to make sure that you make all that wiring successfully.
Right, and it's like you said before, the furnaces, at least on the residential side, aren't changing.
Right.
So everything's going to wire up the same aside from just wiring the sensor.
Yep.
Changing lanes just a little bit. Are there going to be any dry 410A units that we know of?
Yeah, so no. So you may have seen that at the previous refrigerant transition. There were dry R22 units that were shipped and sold for a while, but we're not going to offer anything like that for 410A. So you'll see 454B equipment from us exclusively after the first of the year.
Okay. What about R32? Are we going to have any offerings with R32?
Yeah, so our mini split products will be R32, but all of our central ACs and heat pumps, package systems will all be R454B.
Got it. Are there any changes to filter dryer location?
Yeah, that's a great question. So in the past, we have recommended for corrosion resistance reasons to place the filter dryer inside. Well, there's a new consideration now, and that is that you've got 2 additional braze joints plus the filter dryer itself that are additional possible leak locations that, like we talked about before, are not within our cabinet where our sensor is, right? So our recommendation now would be to place that filter dryer in the outdoor on the outdoor side of the set, on the outdoor side of the system to prevent another possible leak location on the indoor.
Got it. How about replacement parts? I know there's a few that are changing, at least in outdoor unit. So
yeah, absolutely. So there will be new replacement part lists to go with these systems. A lot of components are the same as they were before, but obviously there's new compressors, there's new TXVs, and there's some components that are important to understand that you may not think of right away, like new contactors on the outdoor system and new contactors in our packaged electric heat kits that have been changed to A2L compatible electrical switches. And so if you're doing a replacement, you need to make sure that you're using the correct A2L replacement part in an A2L system.
Got it. All right, well, let's see if here's a good one. Oil.
Yeah.
Does the oil change?
Yeah, so going from 410A to R454B, there is no oil change. So exact same oil as used before. Yep.
Got it. And changing gears a little bit again here. So I think we got time for one or two more here.
Yeah.
Electric heat kits, are those changing?
Yeah, so the air handler electric heat kits are not changing. But as I mentioned a second ago, the package systems that use a contactor, those are changing. So we'll have the same capacities, and actually the actual electric element is the same, but the contactor that activates those elements has been changed to an A2L ready type.
Okay, very good. You may have already answered this a little bit before, but probably not a bad thing to reiterate. With the new MH furnaces, are we going to be able to use 410A coils with those?
Yes. So the way to think about that is if you want to use an A2L system, you need one of our new MH furnaces or an older MH furnace with the conversion kit. But if you have a new MH furnace and you still have an older 410A system you want to install there, yes, you may do that as well. They're fully compatible with 410A.
Awesome.
Yeah.
Well, thanks, Aaron. Thank you all for joining us. I think that's all the time we have. But as always, thank you for watching and participating, and we'll see you next time at the next Lunch and Learn.
Yeah, thanks. Appreciate it.
Thanks.